Video, we will be discussing the second point in our outline here below, and actually I will, since there is no particular interest in looking at me, I will close the webcam, okay? And we will discuss what is defined here as the value of the mechanical arts, and thus this part of our uploaded PDF text. Now, what is the point we want to make here? We want to stress a very simple fact at the beginning. Beyond its usefulness in architectural practice, construction's history's development and its legitimacy as a field of research relies ultimately on the importance we assign to science and technical knowledge in shaping the modern world. If science and empiricism, and by empiricism we mean here the methodology of research in science based on experiment, that is experimental science, as developed initially in 17th century Europe. We have here a drawing of the observation of the phases of the moon by Galileo Galilei at the beginning of the 17th century. If science and empiricism have structured the birth and development of technical modernity, then it also becomes relevant to inquire on how this kind of knowledge has emerged. What were the processes of trial and error through which science has developed? And for us, who deal with architecture, how scientific methodologies, born in the laboratories of the so-called scientific revolution, were transferred in the architectural and engineering professions. It's no surprise then, and here we have the drawings and their published form by Galileo in the Sidereus Nuncius. We have here John Locke, who is one of the theoretical fathers, one of the philosophers who are considered the fathers of empiricism and of modern science. No surprise then that many construction historians, some of them prominent engineers, have considered their task to be similar to that of the historian of science. A whole branch of construction history, in fact, that of the history of structural mechanics, can be directly associated to the history of science. There are even, let's say, ironical ways of putting this connection, of defining this connection between construction history and traditional, we could say, history of science. Jacques Heyman, who is one of the most prominent and brilliant construction scientists with an engineering background of the 20th century, Jacques Heyman, and the 21st, because he's still alive, though quite in old age, Jacques Heyman painted an ironic picture of the construction historian as a scientist by saying that this professional figure, this scholar, is a fully qualified Whig historian. Now, you might not remember it, but the Whigs are one of the two political parties, the Tories and the Whigs, in which traditionally English politics are divided. And the Whigs are traditionally the progressive political party, or who sees itself as more progressive than the Tory conservatives, a party who promotes and believes in the rational approach to politics and to science. And so our Whig historian believes in reason, believes in progress, he firmly believes in progress, and in an objective approach to historical observation. Of course, the Whig historian nurtures also an innate sense of superiority and the tendency to discard the mistakes and the unproductive experiments in construction as irrelevant. But let's say that this connection between the ideal of progress the search in history for the birth of this ideal and the history of science is an interesting node or an interesting intersection that can tell us a lot about the first development of construction history and the first texts that deal with issues in construction history. Now, even if today the history of science has slowly moved away from what has been called the dominant paradigm of modernization, the fact remains that its first development at the onset of modernity in Europe was strongly related both to the myth of scientific progress and to a new interest in social and economic practices. Our thesis here is that construction history lies at the intersection of experimental science and the Enlightenment re-evaluation of technique, well, let's say, represented by the extraordinary work on technique done in the Encyclopédie by Diderot and d'Alembert, published in the 1750s and 1760s in Paris. Now, the Enlightenment re-evaluation of the mechanical arts as a fully dignified topic of philosophical speculation is no less important to construction history than the birth of experimental science itself. Once we consider, just as Diderot and the other French philosophers did, that the knowledge of the carpenter and the skill of the needle maker, which is represented here in this image, épinglier means the maker of needles, and Diderot writes an extensive description of the different actions and manual operations and machines that are employed in the making of the simplest possible object, that is, the needle, demonstrating that the organization of labor is complex. It's not the final result. It's not the complexity of the final result that is important, but the complexity of the process and the procedure. Okay? If we consider these aspects, such as the machines and the actions and the positions of the workers that are necessary to make a needle or to build a brick wall or to build a truss in a historical carpentry, if we consider that these elements or these actions are as relevant as those of the mathematician or the architectural designer, then the inquiry on these trades and professions and on their development in time becomes also legitimate. And we can turn our attention from the scientific knowledge embedded in constructions of the past to the building site itself, its traditions, the workers' actions, and their shared skills.